The Andromeda Galaxy is racing toward us at 250,000 miles per hour. In 4.5 billion years, it arrives. 2 trillion stars begin to collide. Galaxies tear each other apart. The Milky Way, destroyed. Our sky will never be the same. Neither will our solar system. This is the galactic apocalypse. Except for one problem. It might not happen at all. For over a century, astronomers have known Andromeda is coming. Most galaxies rush away from us, carried by cosmic expansion. Andromeda does the opposite. Blue shifted, moving closer, violating the flow. At 250,000 miles per hour, it's closing the gap. Currently, 2.5 million light-years away. Sounds far. It's not. Galactic timescales make it a blink. 2012. The Hubble Space Telescope confirms the collision course. Astronomers Tony Sohn and Roland van der Marel track Andromeda's motion for 7 years. Measure its sideways velocity. Run the simulations. The verdict, head-on collision in 4 billion years. The announcement makes headlines. Our galaxy's fate is sealed. Destruction inevitable. But that conclusion relied on incomplete data. Only 2 galaxies, Milky Way and Andromeda, ignoring everything else nearby. Big mistake. 2024. A new study changes everything. Astronomer Till Sawala at the University of Helsinki combines Hubble and Gaia data. Adds 2 more galaxies to the simulation. The Large Magellanic Cloud. The Triangulum Galaxy. Their gravity matters. A lot. Run the models. Account for all 4 galaxies. Account for uncertainties in mass measurements. Run tens of thousands of scenarios. The result? Only a 50-50 chance of collision within the next 10 billion years. Wait, what? A coin flip. Not certainty. Not inevitable. 50-50 odds whether the apocalypse even happens. In half the simulations, the galaxies pass each other. Separated by 500,000 light-years. They move outward. Then eventually come back, merge in the distant future. Maybe never. In the other half, they collide. But not in 4 billion years, 7 to 8 billion years from now. Even using the latest and most precise data available, the future of the local group is uncertain, Sawala said. Astronomers thought they knew. They didn't. Assume the worst. Collision course confirmed. So what actually will happen? 3.75 billion years from now, Andromeda dominates the night sky. No longer a faint smudge, a massive spiral stretching across the heavens. Tidal forces begin warping the Milky Way's disk. 3.85 billion years. First contact. The edges of both galaxies touch. Gas clouds collide. Compressed hydrogen ignites. Star formation explodes across the sky. New stars blaze to life by the billions. The night sky brightens. Not gently, violently. Blue-white supergiants everywhere, lighting up regions that were dark for eons. 3.9 billion years. Chaos. Andromeda rips through the Milky Way's disk. Spiral arms shredded. Stars flung into new orbits. The galactic structure begins collapsing. 4 billion years. The cores pass. 2 supermassive black holes. Sagittarius, a star, and Andromeda's central black hole, orbiting each other. Massive gravitational distortions. The Sun gets thrown, not destroyed, moved, flung to a different region of the merged galaxy. maybe the galactic outskirts, maybe toward the core. Earth survives, probably. Stars are spaced so far apart that direct collisions are nearly impossible. The nearest star is 4.2 light-years away. In galactic terms, that's an ocean of emptiness. 5.1 billion years. The cores merge. Two bright lobes in the sky. Twin centers. Orbiting, spiraling closer. The supermassive black holes will eventually merge too, producing gravitational waves that ripple across the universe. 7 billion years. It's over. One massive elliptical galaxy. No more spiral arms, no more disk, just a spherical cloud of stars, billions of them, scattered randomly. Milky, the merger product, our new home. But here's the thing. Earth won't care. Not because the collision doesn't happen, because Earth will already be dead. The sun is getting brighter. Gradually, relentlessly. In 1 billion years, solar luminosity increases by 10%. Earth's oceans boil away. Runaway greenhouse effect. All life ends. By the time Andromeda arrives, Earth is a scorched rock. Lifeless. Barren. The collision matters for future civilizations, if any exist, if any survive on other worlds. They'll witness the sky transform. Imagine standing on a planet orbiting a star in the Milky Way's outer regions, safe from Earth's fate, watching Andromeda approach for millions of years. At first, a faint glow, then a massive spiral, then chaos, stars everywhere. New constellations are forming nightly. The sky a churning sea of light. Your sun is thrown into a new orbit. Your planet carried along. Maybe you end up in the galactic core, surrounded by millions of stars. The night sky is never truly dark. Or maybe you're ejected, flung to the outskirts, intergalactic space, alone, isolated. The merged galaxy has a distant glow. No neighbors for millions of light years. Your fate is decided by forces beyond comprehension. Now, the real twist. For decades, astronomers argued about when the collision would happen, but almost no one stopped to ask why it was happening. The universe is expanding. Galaxies drift apart. That's the rule. Everything should be moving away from us. And yet, Andromeda isn't. It's coming closer, breaking the pattern. 2025. Sawala's team looked again, and what they found changed the story. The answer? A vast, dark matter sheet, tens of millions of light-years across, flattened. The Milky Way and Andromeda sit within it, along with other local group galaxies. This sheet changes how gravity works. Imagine this: a massive rubber sheet stretching across space, billions of light-years wide. Place two heavy galaxies on it. It bends. They slide toward the same low point. Now picture something different. A giant sphere of matter. Stand anywhere inside it. Gravity from every direction balances. What's outside your orbit cancels out. Only the mass closer to the center pulls you inward. But a sheet isn't a sphere. The balance breaks. Distant matter doesn't cancel. It keeps tugging sideways. Some galaxies are pushed outward faster. Others are drawn together. Inside this flattened structure, motion isn't random. It's guided, like marbles on a tilted plane. Andromeda isn't special. It's not choosing to approach. It's trapped in the same gravitational structure we are. Both galaxies are sliding toward the sheet's center. This explains the local group's dynamics. Why do some galaxies approach? Why do others recede? Why does the structure look the way it does? The collision isn't random. It's choreographed by invisible dark matter. Despite all this research, uncertainty dominates. The Milky Way's mass? Known to within 20%. Andromeda's? Maybe 30% uncertainty. The Large Magellanic Cloud and Triangulum? Even worse. Their contributions matter, but measuring them precisely remains impossible. Add in 31 other dwarf galaxies in the local group. Each one is tiny, individually negligible. Together, they influence the outcome. Computing that influence requires simulations so complex they push supercomputers to their limits. Sawala's team ran tens of thousands of scenarios. Each one is plausible. Each one within observational uncertainties. Half show collision. Half show near miss. Future Gaia data will narrow uncertainties. Measure Andromeda's motion more precisely. Refine mass estimates. Maybe the odds shift. 60 to 40. 70 to 30. Or maybe they flip. Collision becomes unlikely. Right now, it's a coin toss. The Milky Way and Andromeda might collide in 7 to 8 billion years, or they might pass each other, never merging. We don't know. For a century, astronomers called it inevitable. New data says otherwise. The galactic apocalypse might not happen, or it happens much later, or it's a glancing blow instead of head-on destruction. Either way, Earth won't see it. Our world dies long before, burned by our own sun. But the uncertainty matters. It shows how the universe keeps secrets. Subscribe for the stories that define our cosmic future. If even our galaxy's future is a coin flip, what does that say about how much we really understand? The apocalypse might be cancelled, or just postponed.